Okay, it is time once again for CodingBat. Today we're going to be doing AP-1, the AP-1 section. Let's read the description. APCS medium problems. These problems are based on free response questions from old CPS-A exams, 2004 and later. Some are from the exams and some were just created to have a similar difficulty. These problems are good practice for the logic loop array aspects of the exam. See also the basic recursion section the official College Board CSA page. So these are supposed to be are supposedly you know about AP level difficulty, but this website was made a while ago, so the difficulty has probably changed now. Either way, we're gonna do them. All right, given an array of scores, return true if each score is equal or greater than the one before. The array will be length 2 or more. Pause and try this one. Okay, so all I'm going to do is go through it, starting at index 1, and I'm going to say, is this number greater than or equal to the one before? So if nums is not greater than or equal to the one before, so in other words, if it is less than the one before, then I know that my array does not satisfy the rule, and so I'm going to return false. Otherwise, I'm going to return true, and that will do the job there, or maybe not if I can do that. Okay, there we go. That is how we can do this one. Okay, return true if there are scores of 100 next to each other in the array. Alright, pause and try this one. Alright, and I am going through these pretty quick because, I mean, we just did array 3, and array 3 was a lot harder than these problems are, so I'm going to be going pretty quick. Because I assume, if you could make it through array 3, then this section shouldn't be too hard. Okay, so if nums I equals 100, and I plus 1 equals 100, then return, then return true, return false, and we will be good to go. Again, I used the wrong name. It's fine. I'm just so used to nums, But yeah, we want to go 1 before the end because we're checking the next index here. Alright, so an array of scores sorted in increasing order. Return true if the array contains 3 adjacent scores that differ from each other by at most 2. Alright, pause and try this. Alright, so let's go ahead and solve this one. So I'm going to go through my array, and I'm going to stop 2 before the end because I want to look at the next 2 spots as well. And I'm going to say that the difference between, so they have to differ from each other by at most 2. So I'm going to say the difference between between the next score, I'm going to call, between the next score and the current score at index I, I'm going to call that diff1. And so that'll be math.abs nums I minus nums I plus 1. And then I'm going to have diff2. Diff2 is going to be the difference between nums I and nums I plus 2. So there we go. And then if both of these differences are less than 2, so if diff1 is less than or equal to 2, and diff2 is less than or equal to 2, then we have a winner. We return true. Otherwise, return false. And of course, you could inline this and elide the variables if you wanted to. Given an array of scores, compute the int average of the first half and the second half, and return whichever is larger. We'll say that the second half begins at index length over 2. The array length will be at least 2. They say you can write a method if you want to. Okay, go ahead and try this one. Okay, so we need the average of the first half and the second half. Okay. All right, so let's do this. So I'll call this I'll have sum1, and yeah, and actually I will go ahead and do the suggestion, take the suggestion and make an average method here. So int start, int end, and so what I'll do is I'll say the size of my range, the size of the the range I'm considering is going to be end minus start. And that'll be useful because when I do the average, I'll need to divide by the number of elements I'm considering. And then what I'll do is I'll get the sum as well. So I'll just get the sum and go through the array. So for int I equals 0, I less than, start to end, I less than end, I plus plus, and I'm just going to say sum plus equals nums I, and then return nums over sum. Sorry, not nums over sum over size. And all I need to do is return the maximum of the average of the, I'm going to make this nums as well, the average of the first half and the second half. So average, this is going to have to span multiple lines, average nums.length over 2 nums.length. And there we go. That's how we could do that one. Given an array of strings, return the count of the number of strings with the given length. All right, pause and try this one. All right, so let's go ahead and do it. So this one is, again, pretty straightforward. So for each string, if stir.length is the desired length, we increase the count, and then we return the count. And there you go. There is a shorter way to do this, which again I'm going to tell you but not really explain. We could also say return arrays dot stream words filter s2 length equals len dot count. So this is another way to do it as well. Okay, so return a new array containing the first in strings in my array. All right, pause and try this one. All right, so hopefully you remembered from the array1 video that there is already an existing method to copy a range from an array. So I could just do words0 to in. Now this might, okay, never mind. I was about to say it might not work, but it does work because, yeah, let me just look at the copy of range method real quick. Arrays.copy of range. Oh yeah, so you can pass it an array here. This T just stands for any reference type. So it will, detect whatever reference type you're using as your array, and it'll return an array of the same type, which is awesome. Okay, so that is very nice there. You could do this manually. I'm not even going to show that because I think if you've been able to do the problem so far, you can definitely do that. All right, so an array of strings, return a new list, for example, an ArrayList, where all the strings of the given length are omitted. See wordsWithout below, which is more difficult because it uses arrays. Okay, so if you can hear the dog, my apologies, by the way. Okay, so we need to return a list. So basically, we haven't talked about lists, and we need to talk about them. So here's what a list is. So basically, if you want to create a list is like an array, but its size can change, right? We know that the size of an array is fixed when we create the array, but with a list, the size is not fixed. So here's how we create a list. So if you want to create a list, you put in, to denote the type of the list, you say the word list, and by the way, you have to import this. It's in the java.util package. A package is just a big group of classes, and list is what we're going to use is a class. So I'm going to import this all here, and then we'll have access to the list type here. And so inside of these angled brackets, these are just less than greater than signs, you put the type of the thing you want to store in your list. So like list integer. And then let's create a variable, just call it list. Or we'll just call it, we'll call it nums, sure. And then to create a list. So lists are like a useful structure. They can store elements. We can add elements and remove elements, and the size can change. We can access them by indices and stuff like that. We can get the size of the list. We can clear the list, etc. So there are different kinds of lists. And one kind of list, the only kind of list we're going to talk about in the CodingBat series, is the array list. So here's how you make an array list. So you just say new array list, and then you put in angled brackets the type you want to create, the type of the array list you want to create, and then a pair of parentheses at the end. So this line here will let us create an array list with this as its name. So basically, what's going on here is that this array list is a kind of list. And what we say in coding, or in Java, is that array list is a subtype of list. So let's say you have you're creating a variable, right? So the thing on the right, the type of whatever you put on the right, whatever you assign the variable to, has to agree with the type on the left. So in other words, this type here, array list integer, has to agree with the type list integer. And if the type on the right is a subtype of the type of the left, then they agree. To give you another example, there's something called object. An object is the supertype of all types. It's the mega overlord. It's the supertype of everything. So, for example, we know string is a reference type. So I can assign this variable o, which is an object, I can assign it to a string, like hi. Because the type of the thing on the right, which is string, is a subtype of object. String is a subtype of object because everything is a subtype of object. I could also say o equals nums, because nums, the type of nums is a list, because that's what it was declared as. And I assign it to o, which is fine, because the type of this is is list, and the type of this is object, and list is a subtype of object. So that's how we can basically make a list. And so you can add to a list by doing by just doing nums.add and then putting things you want to add to the list. And if you print out a list, it will already be printed out. It will print out in a nice, well-formatted way. So if I added some other numbers, like if I print it out now, it's just 3. If I go ahead and I add some other numbers, I say add like 7, and then I print it out, then now it'll have 3 and 7 in it, and its size will be 2. So I can print out, size equals plus nums.size, and now that's the size of the array list, or the list. So that's all well and good. I want to mention why I'm using integer here instead of int. If I try to use int, you'll notice that it won't compile. It won't work. So I have to use integer. And that's just because you can only make lists of reference types. So like the elements of your list can only be reference types. And we know that int is a primitive type, not a reference type. Now what integer is a type, it's kind of like string, it's treated very specially by the language. And basically you can convert, this is a simplification, but you can convert from ints to integers and vice versa. So int primitive type to integer reference type. You can convert between them implicitly, like it'll be done automatically for you. You can just go between them, go one way or vice versa, whenever you want. So that's why I can add this thing here, which is an int, to my list of integer, whose whose element type is integer, and that is totally fine. So that's what's going on here. There are other types, like if you wanted to do chars, you would have to do the character reference type, or the double reference type, or if you wanted to do doubles, or the Boolean reference type. But we're doing integers now. So that is basically how they work. And so whenever you have a reference type, this is just a brief detour. So we're detour within a detour here. So let's say you have like a reference type, right? Let's say it's like a string, whatever. It has some memory address, 118119, and then it points to a place in memory as we've discussed before. So let's say like here are the memory cells that it points to, and it contains the text, hey, H-E-Y. That's the text it contains. And my string, this 3 is just like the length of the string. So this memory address, as we all know, points to this spot in memory. So this thing here, this thing right here, we all know is called the pointer or the memory address or the reference here. But this thing here, this actual thing in memory, is called the object. So this is the object. This is called the string object because it's a string. So this is the reference that refers to this object. So lists can only store objects, right? Because only references can point to objects, and only reference types store references. Okay, so that's what we can do with a list. We can add to it, and we can print out the size. We can print it out by itself, and it'll print out nicely formatted for us. And that's all well and good. If you want to get the value at a certain index, you can do that as well. So I can say nums.get 0. That'll get the element at index 0, which is 3. So that's great. I can also set at a certain index. I can say nums.set. And then what you do is you pass to the set method, you pass the index you want to set. So like let's say I want to set index 1 to 20. And so now, well, okay, now I need to print out, sorry, I don't want to be printing out the set. I want to be printing out the array list after, sorry, the list after that. So now that I've set index 1 to 20, now the list looks like that. So we can add elements, we can get at a certain index, we can set at a certain index. There are plenty of other things you can do with a list, which we can talk about later. But for now, this is going to be good. This is all we need here. And also notice that you don't specify the size of the list, right? By default, you create a list, its size is 0. It's empty, it has nothing in it. But as we add more elements, its size will increase. If we remove elements, it'll decrease. I guess I'll tell you one more thing. If you want to remove an element, so if you want to remove an element at a certain index, you just do the list, you type .remove, and you pass the index you want to remove. So let's remove the thing at index 0, and now if I print out nums, it just contains the one element, 20. So that's another thing you can do. You can remove the element at a certain index. Okay, so let's go ahead and go back to, not Paint, but CodingBat. Okay, so it says return a list. Now this really should say integer because we're doing integers. We want to return a list of integers, or sorry, not integers, of strings. But sometimes if you leave off this, it can cause problems sometimes, and it's not recommended to leave off this. So I don't know why the problem creator did that, but really it should say list. It should say string here. So okay, so go ahead and we'll create a new array list. So we'll say list string equals new array list. Now you can actually omit the reference type here. It's optional. So I could put the word string here, or I could omit it. It'll be inferred if I omit it, so the compiler will figure out what I mean if I omit it. But you can also explicitly put it if you want to. I'm going to omit it though. Okay, so now I have my array list. Well, actually, let me put a name here. Call it list. And all I need to do is take the first len items out of my words array and add them into my list. So I'll say for int I equals 0, I less than len I plus plus. And then I'm going to add, I need to add, let's see. Oh, sorry. I need to actually read the directions is what I need to do. Okay, so all the strings of the given length are omitted. So I need to go through my my words array. I'll say s:\words, and then if this string has the length it asks for, then I'm going to not add it. So in other words, if it doesn't have the length, I am going to add it to my list, and then I can return. Sorry, not s, but the list. And so there we go. That's how we could do this one. Yeah. So yeah, that is how we could do this one. Yeah, I don't think there's anything else I want to talk about here. All right, given a positive int in, return true if it contains a 1 digit. Note to use remainder, the remainder operator, to get the rightmost digit, and / discard the rightmost digit. Okay, so pause and try this one. Okay, so I might need to adjust my microphone here. Okay, so this problem wants you to use remainder and division, but I'm not going to do that. All I'm going to do is I'm just going to say, does the string form of it contain a 1? If so, it contains a 1's digit. That wasn't too hard. But if you want to do it without converting it to a string, I'll show you how you might do that. So what I'll do is I'll say while in is greater than 0, then if the last digit right now is a 1, then we found our 1, return true. And then otherwise chop off the last digit. So by doing in divide equals 10, this in other words, this is saying in equals in divided by 10, so that'll remove the last digit from in. And then I just need to return false if I never find a 1. So that's a way to do it if you don't want to convert it to a string. Okay, so a positive int divides itself if every digit in the number divides into the number evenly. So for example, 128 divides itself, since 1, 2, and 8 all divide into 128 evenly. We'll say that 0 does not divide into anything evenly, so no number with a 0 digit divides itself. Alright, go ahead and pause and try this. Alright, so I'm going to make, because I'm going to be, so I'm going to make a copy of x. I'm going to make, in other words, another variable that equals x, or sorry, that equals in, so that I can leave in unchanged, because I'm then going to need to compare each digit to in order to see if it's divisible. So I'll say x equals in, and then x is what I'll divide and chop up and find the digits of. So while x is greater than 0, this will basically let me get the digits. So the current digit is going to be x remainder 10. And then I can just go ahead and chop off the last digit because I've now retrieved the one I want. And so if this digit divides in evenly, then we're good. If it does not divide in evenly, then we need to return false. And then otherwise return true. And oh yeah, one thing we want to check is that if n equals 0. So you can't do remainder by 0 just because you can't do division by 0. If you try to do division by 0 in Java, your program will crash. You'll get an arithmetic exception, or arithmetic exception. So we also want to say if n equals 0, then return false, as the problem statement says. So sorry, not and, or. There we go, almost. Sorry, not n equals 0, digit equals 0. Okay. And there we go. So that is how we could do this one. Notice if we didn't have x and we just started dividing in, well, we could no longer see if this digit divides the original in because we've lost the original in because we've chopped off digits from it. So yeah, that's how we could do this one. All right, so given an array of positive ints, return a new array of length count containing the first even numbers from the original array. So okay, the original array will contain at least count even numbers. Okay, pause and try this one. Okay, so I'm going to just make a new array of length count, and I'm going to go for each number in nums, and I'm going to make a new index actually called R index. That's going to be the index of where I'm adding to, where I'm currently at in R, where I'm adding to. So I'm just going to go through my nums array, and whenever I find an even number, I'm going to add it to my array. And let's see. Actually, what I'll do is I can just go through, using an enhanced for loop, go through each number in nums, and I'll say, okay, if this number is even, then add it basically to R. So I'll say, yeah, if this number is even, then say R index equals this number. And then I need to increment R index so that next time I add to the next spot. And then I'll also say down here that if R index is equal to the length of the array, is equal to count, which is the length of R, then we're done. We've reached the end, so break out of this for loop. And then I'll return, sorry, not R, but nums, sorry, not nums, but R at the end once we're done. So that's how we could do this one. Another way I could do this is I could say, so just to give you an alternate solution, I could also do go here, and I could go and say, I could create also, in addition to an R index, I could do a nums index that starts at 0. And I could say while R index less than, actually rather while R index is less than R.length, I just go through and, or actually, yeah, I'll do it based on nums index. So while nums index is less than nums.length, I'm going to say the current number, I'll call it in. So int in is going to be at nums index. So if in is even, then R index, then R at R index equals in. And then what I'm going to do is I'm going to just increment R index here, of course. And I'm also going to make sure that this while loop stops when R index is less than R.length, which we know is count. So this is another way of writing it. here. So, oh, or maybe not. Yeah, we also need to make sure we're incrementing num's index too. That would probably be good. Yeah. So there we go. That is an alternate way of doing this one. All right, so a positive int n is indy if it's in the range 0 to 10 or 90 to 100. Given an array of positive ints, return a new array of length count containing the first indy numbers from the original array. Decompose out a separate isIndy method to test if a number is indy. The original array will contain at least count indy numbers. Go ahead and pause and try this. Okay, so this problem is very similar in structure to this, so I'm actually just going to, if you don't mind, do this. And now it's called copyEndy. So instead of just rewriting this code, all I need to do is instead of asking for is this even, I need to just say is in indy, which would mean that in is between 0 and 10, or in is between 90 and 100. Okay, so that's how we could do that one. Yeah, I didn't really feel like writing all the code again. If you wanted to do the decomposition, as he called it, or in other words, write a helper method, you could do it like that. All right, given two arrays that are the same length containing strings, compare the first string in the one array to the first in the other, second to the second, and so on. Count the number of times that the two strings are non-empty and start with the same char. Pause and try this one. All right, non-empty and start with the same char, so I'm going to get a count going and go through my arrays. They have the same length as we're guaranteed. And so basically, if, so I'll get the two strings. I'll get a string, actually I'll just call them x and y. X equals ai and y equals bi. So if x, so x is not empty, and b is not empty, sorry, y is not empty, empty, and x.char at 0 equals y.char at 0, then increase the count, and then just return the count. Pretty straightforward one there, yeah. Right, the key array is an array containing the correct answers to an exam, like A, B, A, B, B. The answers array contains a student's answers with a question representing a question left blank. The two arrays are not empty and are the same length. Return the score for this array of answers, giving +4 for each right answer, -1 for each incorrect answer, and 0 for each blank answer. All right, pause and try this one. All right, so here's how we'll do this. I'll get the score going, and the score will start at 0, and I'll add 4 for every wrong answer. Or sorry, I'll add 4 for every right answer, and remove 1 for every wrong answer. So here's what we'll do. We'll go for each index, 0 I less than key.length. And I'll say if, well, I'll get the student answer. I'll get the correct answer will be key at index I, and the student answer will be, and in fact, I'm not even going to bother with these variables. So if the student's answer, which is answers I, equals the key answer, then we add 4 to their score. And then otherwise, if their answer is not a question mark, so if they didn't leave it blank, then we know they got it wrong. So then I'm going to subtract 1 from their score. And sorry, I should be incrementing 4, not 1 there. And then we can omit these, I suppose. And then we can just return their score. And let's see. We expected 3 there. And sorry, if it does not equal a question mark, if they did not leave it blank, would mean that it is not a question mark. Okay, there we go. All right, return a new array without the strings that are equal to the target string. Pause and try this one. All right, sometimes they just give you too many words in the instructions, so I got to omit them. Okay, so for, okay, so let's see. So return a new Okay, so what I'm going to do is I'm going to show you something you can do with lists. So if maybe you can see that if the return type of this method was list instead of string array, so if this was list instead of string array, then this problem would be easier. So actually there's a nice method on lists that just lets you convert a list to an array. It's a very cool method, very simple method. So here's how we can do that. So I'll basically create a list of strings. That'll be my list, not list, a list here, and we'll go for each string in my words, and I'll say if this string does not equal the target, so if it is not the target, then add it to my list. And now all I need to do is convert my list to an array. And so here's how you can do that. You can just say list.toArray, and then inside these parentheses you pass the type, you put the type of the array you want, and then you do : new. If you'd like to go down a rabbit hole, this thing here that I just highlighted is called a method reference. Method reference Java. You don't need to put 8. But yeah, if you want to go down a rabbit hole, you are free to do so. But this is called a method reference, and it lets us tell toArray what type our array should be. And so, okay, let's see. Actually, I think this might, let's see. This.toArray. Okay, sorry. Let me go this.toArray. Let's see here. Sorry, okay, let me see if I can find the thing I'm trying to find. Okay, so here it is. Oh, and okay, so this method I'm using is too new for CodingBat. So never mind, you can't use this method. But there is another way you can still convert a list to array easily. And so what you do is you pass an array of length 0. So you pass an array of the correct type, but of length 0. I know it's weird. I'm sorry. I wish it could just know what type you wanted. But yeah, I can't. So yeah, that's how you can convert a list into an array relatively easily. So that's how we could do that. Yeah, let's see. So there is a more concise way of doing this, which I'll just show you. I'll do a show. I'll show it, but I won't really explain it. Like I've done before. So sorry. So basically what we can do is we can do a little bit of this. And let's see. Sorry. I might need to just check something real quick. Okay. Okay, and it looks like, okay, so I think I can actually, oops, let me go over here. I think this time I will actually be able to do the string array : new stuff. Okay, so yeah. So this is a more concise way of doing it if you would like to look into it. Oops, okay, I skipped one. Yeah, okay. All right, given two arrays of non-negative scores. You're given two arrays, okay. A special score is one with a multiple of 10, which is a multiple of 10, such as 40 or 90. Return the sum of the largest special score in A and the largest special score in B. Go ahead and pause and try this. Okay, so I'm going to take their suggestion, and I'm going to say largest special. I'll just say yeah. Okay, so for each, so what I'm going to do is I'm going to say, so let's see. So it looks like I should return 0 if I don't find any special scores. I'm going to assume that if like there's not a special score in one of them, I just don't add anything for that array. So what I'll do is I'll go through here and I'll say for each number here, if this number is special, then max equals the maximum of its current value and in, then return max, and all I need to do is return, it says the sum of the largest special in each one. So largest special of A plus largest special B. Okay, and that's how we could do that one. All right, so we have an array of heights representing the altitude along a walking trail given start/end indexes into the array. Return the sum of the changes for a walk beginning at the start index and ending at the end index. For example, with the heights 5, 3, 6, 7, 2 and start equals 2, end equals 4, yields a sum of 1 plus 5 equals 6. So yeah, the start and end index will both be valid indexes into the array with start less than or equal to end. Go ahead and pause and try this. Okay, so here's how we could do this. So I'm going to have a sum. It's going to start at 0, and I'm going to go from start up to, but not including end. And what I'll do is I'll say, okay, what's the difference between this one and the next one? So guess what heights? You're now nums. Nums I minus the next one. And whatever this difference is, I'm going to add to a sum. So I'm actually just going to do sum plus equals this, and then return the sum. And so that's how we could do this one. All right, so we have an array of heights. Return the sum of the changes for a walk beginning at the start index and ending at the end index. However, increases in height count double. Pause and try this. All right, so maybe you could guess what I'm going to do, and it's called a little bit of this. Yes, that's actually what it's called, a little bit of this. So if it is an increase in height, it's going to count double. So if it's an increase in height, then the next number, I plus 1, is greater than what we're currently on. And if that's the case, then basically I'm going to add 2 times that difference of nums I plus 1 minus nums I. And otherwise, I'm just going to add whatever nums I minus nums I plus 1 is, because now I know nums I is bigger than nums I plus 1. So that's how we could do, if we rename the variable, that's how we could do this one here. All right, an array of heights, return the number of big steps. Starting at the start index and ending at the end index, we'll say a step is big if it's 5 or more up or down. Pause and try this one. Right, so you'll never guess how I'm going to start this off. It's by copying this. I just love to hit the go button. Okay, so if the difference of nums I to the next one is greater than or equal to 5, and it's a big step, and so I'm going to have a count of the big steps, and if I find a big step, increase the count. And again, rename the variable. And again, be bad at coding and have compile errors. Okay, so there you go. That'll count the number of big steps that we have. Okay, so let's keep going. All right, these problems are long. They really are AP problems. Okay, so we have data for 2 users, A and B, each with a string name and an int ID. The goal is to order the users, such as for sorting. Return -1 if A comes before B, 1 if A comes after B, and 0 if they're the same. Okay, so order first by the string names and then by the ID numbers, if the names are the same. Note, with strings, star1.compare to star2 returns an int value which is negative or 0 or positive to indicate how star1 is ordered with star2. The value is not limited to -1, 0, or 1. Okay, so go ahead and pause and try this one. And actually, let me say something about this method. So, because we haven't talked about it. So, if star1 comes before star2 alphabetically, this will return a negative number. If stir1 is equal to stir2, then this will return 0. And if stir1 comes after stir2 alphabetically, this will return positive 1. Or sorry, not positive 1, but actually any positive, some positive number. So negative if stir1's before stir2, 0 if they're equal, and 1 if stir1's after stir2 alphabetically. Okay, so now pause and try this. Okay, so if, well, first what I'm going to do is I'm going to get the, I'm going to compare them. And I'm going to get whatever value compare to returns. And I'm going to just call their names actually A and B, just so it's shorter. So comparison, I'm going to call this, I'll call this comparison, or comp for comparison. I'll do a.compare b. And so if the comparison is not 0, then I know that their names are different, and I just need to sort them based on their names. I don't even need to consider their ID numbers. So if the comparison is less than 0, I return -1. So if it's, so if the comparison is negative, I return -1. Otherwise, I return positive 1. And then what I do, and of course you know that you can do that if you want to. So then what I do is I say, okay, their names are equal. They must have the same name. So what I do is I say if A's ID is less than B's ID, I return -1, and otherwise I return positive 1. Or actually, their IDs could still be equal, so I'll need to check if A ID is greater than B ID, then I return 1, and then if neither one's less than nor one's greater than, then they must be equal, so I return 0. They are the same user, and it is compared to not compare. All right. So that is how it works here. Yeah, so that is how we could solve this one. This idea of like a method, a comparison method that gives you negative number if first one's less than the second one, 0 if they're equal, 1 if first is greater than the second one. That idea like is a common thing in Java, and so that's why that's how this method is how this problem is asked. So it's not just like a random arbitrary thing that the problem creator made up. Um, that is actually commonly how you might indicate whether something's less than, equal to, or greater than something else. All right, let's keep going. All right, so start with 2 arrays of strings, each with its elements in alphabetical order and without duplicates. Return a new array containing the first n elements from the 2 arrays. The result array should be in alphabetical order and without duplicates. A and B will both have a length which is n or more. The best linear solution makes a single pass over A and B, taking advantage of the fact that they are both in alphabetical order, copying elements directly into the new array. All right, pause and try this one. Okay, yeah, so let's see. So yeah, I'm going to go ahead and go ahead and start by just doing the linear pass strategy, the efficient strategy. And we'll go ahead, yeah, and just do that. So my result array, I'll call it strs, sure. And it will contain in things. And then what I'll do is I'll have 2 indices. I'll have an A index. I'll actually just call it AI, and a B index. Okay. And then here's what I'll do. So I'll go through and I'll say, okay, so, and I'll also have, actually, I'll have a strs index. I'll call it SI for stir, the index in strs, the strs array. So here's what I'll do. I'll say while stir, but while the stir index, actually, I don't even need to do that. I'll just have that as my loop index. So for, I'll just call it I. I'll say for I equals 0, I less than strs.length, and I can actually just say in. Okay, so what I'll do is I'll say, I'll compare the 2 elements that I'm currently looking at. The element at array A at index AI, and in array B at index BI. And I'll compare those 2. Whichever comes first alphabetically, I will add to strs, and I'll put at index I in strs. And then I'll increment whatever index. So if I took a word from the A array, I'll increment AI by 1. If I took a string from the B array, I'll increment BI by 1. And I'll also need to be careful if they're duplicates to take 1 from one of them, but increment both counters, because I don't want to have duplicates in my strs array. So I'll get those two strings here. So I'll say a star equals a. Well, first of all, let's see. So if I run out of strings in one of the arrays, actually wait, let's see. It says both will have a length in or more, so I don't need to worry about running out of strings in either of the two arrays, A or B. So what I'll do is I'll say if, and I'll actually get the A string and the B string. So A string equals AI, and B string equals B at BI. Okay, so I'm going to say if the A string comes first alphabetically, so if A dot compare to B, B star is less than 0, so if A comes first alphabetically, then and actually I'm just going to get this comparison as a number, so I'll say int comp for comparison. So if the comparison is less than 0, which is going to mean A comes before B, A star comes before B star alphabetically, then what I'm going to do is I'm going to add, I'm going to set stars I equal to the A string and increment the A counter. And then if the comparison was greater than 0, I'm going to set it equal to the B string and increment AI, and then and then basically if they're equal, so otherwise I know that the comparison equals 0 and the two strings are equal. So all I need to do is say stars I equals A star and then increment both counters. And the reason I'm incrementing both counters is because let's say I incremented one but not the other. Well, on the next pass, I would be looking at I would still, like, let's say A and B, both arrays had the string x. So I pick one, let's say I pick the A string x and I increment A's counter. I increment AI by 1. Well, now, next time I go through this for loop, B still has the string x at index bi. And so I might end up adding x again to my result array. But the result array is supposed to have no duplicates. So yeah, let's see, right? The result array in alphabetical order without duplicates. So now I should just be able to return whatever I called it, stars. And let's see, stars would be better. And let's see, okay, so I'm still having some duplicates here. Let's see. Okay, that's because I'm incrementing AI there when I should be incrementing BI. There we go. One thing I will note is that notice how this logic that I just highlighted can be rewritten, I think, by doing this, and it'll be equivalent. Um, so you don't like me anymore, CodingBat? Wow, I see how it is. What's wrong? Okay, so curly braces or curly braces. We got this. What? I'm like, so that's fine? No, that's not fine. What did I do? I do that and now all of a sudden you hate me? What happened? Oh, because I put it in the wrong spot. Okay, that's fine. Okay. So, okay, that's how we go. That's how we do it. Okay, so yeah, so I believe, yeah, it could be rewritten like this and it would be equivalent. Okay, there we go. All right, so yeah, that is how we could do this one. Because I just can't help myself, I'm going to show you another way to do this that's not efficient. Like, it's not the most efficient. It's not efficient as what I just wrote, but it is more concise. So basically, well, I'll explain it a little bit. Basically, there's a type of collection called a set, and a set doesn't allow you to add any duplicates. If you try to add a duplicate, it'll just say no. Like, it won't crash your program, but it just won't add it. It won't actually add it if you try the call to add method. So I can create a set here. And one kind of set is a hash set. So this is similar to like list and ArrayList. A hash set is a subtype of set. And what I can do is I can add all the elements from A to set and all the elements from B to my set. And let's see. Yeah, and actually, I'm actually not going to use a set. Yeah, let me use a list instead. We don't even need to worry about sets. So what I'll do is I'm going to add, okay, so I'm going to add everything from A and everything from B into my list here. And the collections.addAll method is just a useful method that takes in a list and an array, and it will add everything from the array into the list. So what I'm going to do is I'm just going to sort my array by doing collections.sort. This is another useful method. You'll never guess what it does. And then I just need to basically return, there's a method in list, in the list type called sublist, which again, you'll never guess what it does, but it's like a substring, but from a list. Just like how we talked about subarrays. There's no method that makes a subarray, but there is a sublist method on lists. So pretty cool. So the sublist method, again, first index is the first, like the index of the first item you want in your sublist, and the second index is the index after the last item you want in your sublist. So I'll go from 0 to n, and then I will just make it into an array, which is what the problem wants. And we do that like this. And now, and now, and now we make sure that we put string instead of integer. And now we, let's see, in order to, in order to get rid of the duplicates, let's see, here's what I'll do. I'll first put it into a set, so this will be a set instead. So I'll first put everything into a set, and then I'll put everything from that set into my list. So to add everything from one collection into another. By the way, lists and sets, they're both subtypes of a even broader type called collection. And so collections have their own common, methods. So the way you add everything from one collection into another. So let's say I want to add everything from set into list. I can just say list.add all from set. And there we go. Or never mind. Maybe that's not how we go. Okay, so then we add everything from the set, and let's see. Okay, so yeah, maybe we add, A and B, not A and A. Okay, there we go. So this is another way to do this. Now, one thing you can do when you're creating a list is if inside of these parentheses you pass in another collection, it'll actually just make this array list by default have everything from this collection. So this is another way to write this one here. Yeah, that is all I have to say about this one. Again, don't have to worry about all this collection stuff. You could just do this if you wanted to. All right, this is the last one of the AP section. Start with two arrays of strings, A and B, each in alphabetical order, possibly with duplicates. Return the count of the number of strings which appear in both arrays. The best linear linear solution makes a single pass over both arrays, taking advantage of the fact that they are both in alphabetical order. Okay, pause and try this one. Alright, so it is the number of strings which appear in both arrays. And it says possibly with duplicates. So, okay, so possibly with duplicates. Okay, let's see. So it doesn't give us any examples of that in the test cases, but we will need to handle that. So let's go ahead and do this. So I'll say count starts out equaling 0. So, all right. So I'm going to have, let's see, I'll have an A index and a B index. So, let's see. So yeah, I'll call it AI equals 0, BI equals 0. And I'll say while AI is less than A.length, yeah, so basically I'll say while AI is less than A.length and BI is less than B.length, what I'll do is I will compare the two numbers in the array. Let's see. Sorry, not the numbers, the strings. Let's see. Let's see how exactly I want to do this. So, what I'd like to do here is just find basically whichever one. Okay, so basically, if one of them comes first, I want to. Okay, I'm not making any sense. Let's see here. So I'm gonna say I'm gonna get the two strings at these indices. So I'm gonna say string A string equals A at index AI, and then string B string equals B at index BI. And I'm going to say, okay, and then I'm going to compare them also. I'm going to say int comp equals A stir dot compare to B stir. And I'm going to say, okay, if A comes before B alphabetically, just increment AI. That's all I want to do. And then if B came first, then increment BI. But otherwise, if they're equal, so this we'll go into this else block here if they're equal. So if they're equal, then it occurs in both strings. Sorry, I found a string that is common to both arrays, and so I increment my count. Then I return my count. Now I don't think this handles duplicates, or not. I don't think I know it doesn't handle duplicates. And let's see. What have I done here? So, oh yeah, if they're equal, I also of course want to increment both of them as well. Yeah. Okay. So this is not, yeah, this does not handle duplicate situations like that. So what I'll do is I'll say, before I go into the loop, or before I do anything else in the loop, I'll skip past any duplicates. So I'll say like, while AI is less than a.length minus 1, and the current value in a at AI is equal to the next one, so a at AI plus 1, just increase a, just skip it, because I honestly don't want to have duplicates. I don't want to deal with these duplicates, so I'm just going to increment it and go on. So yeah, and then here, of course, I'm going to do B instead. I'm going to say, I'm going to actually be kind of person who do that. Okay, so basically I'm going to skip past duplicates before I do anything else in the loop. And I'm going to make sure to forget my parentheses, and then I'm going to run it. All right, there we go. So this this basically lets me skip past the duplicates. Now, I may have done that. I probably did this out of order, but if you want to do a simpler solution that didn't take advantage of the fact that they're both in alphabetical order and didn't make a linear pass, I could also just do, and actually I'm going to not zoom in, but I'm going to comment this out so I can show you a different way to do it. So this way is not as efficient, what I'm about to show you, but it's, I guess, simpler to understand. Let me delete all this. So I'm going to write a quick contains method, Boolean contains. That's going to take an array and a string and determine if the array contains that string. So if the array A contains that string. So I'll say for string s colon A, if s equals x, return true, otherwise false. And then what I can do is I can just go through A and say if B contains this. So if B contains this string, increment the count. And as I mentioned before, make sure to forget your parentheses. And then that is how we could do it. Or let's see. Oh yeah, we also need to worry about duplicates. So what I'll do is in order to get rid of the duplicates in A, I'll just actually convert it to a set. So I'll just make a set of strings. I'll call it a set. It equals a new hash set. And what I'll do is I'll just add everything from A add everything from A into A set. And then you can actually loop over. We've talked about how you can do enhanced for loops with arrays to loop over arrays. You can actually also use enhanced for loops to loop over collections. So I can actually just loop over A set here, and that will do it here, because now A set doesn't contain any duplicates. It contains the same thing as A, but without the duplicates. So that is how we could do this way, and this one and this is, of course, I think a more understandable solution than this one down here, but this one down here does. It is more efficient and takes advantage of the fact that they're sorted already. So that's the AP-1 section. I know I did it pretty quickly. But yeah, hopefully you learned about lists and sets and well, a little bit about sets. Sets were not the main focus here. But yeah, hopefully you learned about lists. Those are really useful, and we'll actually see them come up in some later sections, like I think these two sections here. Yeah, well, lists, it's right there. Okay, so yeah, that was AP1. We'll next time we'll work on recursion 1, which is really cool. We'll have methods calling themselves in recursion, so some interesting stuff there. But that is all I have for this video. I've recorded like 5 hours of CodingBat today, and my voice is getting kind of sore. So I will see you next time for recursion 1. Goodbye.